Okay, hello everyone. Um, I hope you have scanned the QR code. And in today's lecture, we will continue what we from the last part from Friday course. Okay. And also at the end of our lecture, I would like uh, to have some feedback from you, especially about the midterm. So that will be on the end of the lecture. Okay. Now let's start today's lecture with the uh, some a little bit review, okay, review of fundamental theorem of calculus. Okay, so there is two sections of the theorem. The first one is this. Okay, so when we have the g of x is integration from a to x. If we are going to differentiate, this will be resulting. Okay, and we have some uh, some notes regarding the proof, right? So whenever you have some a like this, any a, okay, you can actually at the end of the result you can cancel this a within, and then it's just resulting just x, and then put into the variable t here and integration, and it became f of x. If for example you have gx, this is from 0 to x, and you have square root of 1 plus t squared and then dt. And g prime x, or the first derivative of g, simply we can write square root 1 plus x squared. Okay, there's nothing uh, complicated here. What you are looking at is you can just change the t squared with x. Okay? Now what will happen if you, this is, let's say, a, b. If you have g of x is, or let me write differently, maybe h of x. This is from 1 to x with power of 4. The secant t dt. What is h prime x? Any idea? Secant? Secant x with power of 4 and then dx. Okay. Okay. Now this becomes more a little bit have some complications. Okay, so you have the integration from 1 to x with power of 4. Okay, now if you have something like this, of course it will be a little bit different with the first one. The first one, I think it's simple. It's 0 and then x. Okay, it's just an x. If we have x with the power of 4, what I can give you some advice is let u is x with power of 4. Okay, let's say we have this u, and let's write down this u like that, and this will be secant t dt. So if we try to first, we take this d du, okay, not d dx. Okay, that is we have secant u, yeah, secant u, right? And then from this secant u, we take this d dx. Or maybe we can write here that is secant u, or let me just directly write d dx here, and then this will be changing to d du of this, and then du dx. So we have secant u and then du dx. Du dx, if we look here, du dx is 4x cubed. Now we have secant. Let's write the whole thing with x with power of 4 and then multiply with 4x cubed. So we need to have some chain rule, okay? Some chain rule from the derivative part. Okay. So let's look back at here. Okay. So if you're just having just x, okay. So this is the first one is just the original formula. We just change the t with x, okay. But if we have the variable of x is having some forms like x with power of 4 or 2x or 3x or maybe ln or any functions, and it become a function, okay, then we need to derive this integral with the chain rule. Okay, so my idea is, or my advice Okay, how about now? Okay, can you hear? Okay, okay. Okay, so yeah. So uh this is the theorem for part one. Okay. So I hope you guys can see and observe on how we are using this theorem. Okay. And if we have something like this, the integration have a function, then we can use some chain rule. That's why we have this 4x cubed at the end of the result. Okay. That is from x with the power of 4. We derive one time, and that will be our result. Okay. Okay, the next part is about the net theorem. Okay. So this will result with or resulting the antiderivative. Okay. Or in our case, it's still just e. Or sometimes we use the notations, maybe um, with the antiderivative and then evaluate from A to B, or we can write this FB minus FA. We can sometimes write the antiderivative like this. Okay, okay. Okay. What we will have here? What is the result? Anyone can? If you have solved, you can write the solution on the chat box. Okay, x with the power of -2 or 1 over x squared, right? Mm-hmm. So, mhm. Yeah. Mm-hmm. Mm-hmm. Need to derive antiderivative of the x with -2, right? Mm-hmm. Mm-hmm. Okay. What's the result here? 2 over 3, really? I think you do need the negative here, right? Right, right. Okay. Okay. All right. Okay. 2 over 3. Okay. Anyone have different answer? Okay. Yes, yes, the zero part. Yes, correct. Look at this integration here. Okay. This is the interval. Let me write the interval. Okay. This is from -1 to 3. Okay. Now our uh, integrations is, let me write in another terms. Okay. The questions is, before we integrate, we need to ask ourselves, does function continues? That's the first thing. Okay. Even though I check how you calculate the integration and some still wrong, but before the calculation start, we need to check the continuity. Okay. So if we check from this interval here, okay, from this -1 to 3, we will notice that the when x is equal 0, okay, so when x is equal 0, the functions is not continuous, right? Or we can write completely the functions, that is the 1 over x squared is not continuous. So we can simply say that at the summary, so this integration does not exist. Okay. Later, I think at the chapter 7, I think, yeah, we can try to approach this type of integral. We call the improper integral, but that will be a later part of our chapter. So this is the let me write here so that you can remember improper integral on chapter 7. But in general, this integration will not exist. Okay. Now at the end, these two part of fundamental theorem of calculus, this will be uh, regard as uh, how we are connecting the derivative to integral. Okay, so if we have these two, okay, if you look at the first one and the second one, both are linked together, okay, so that you can connect, okay, derivative, okay, and the integral. Okay. And the same way, the second part also the integral with the derivative. If we have the uh, compute the antiderivative, it will be the first derivative is just the original functions, right? Okay, let me give you maybe some examples, or maybe 2 or 3 more examples on this part, fundamental theorem of calculus. Okay. Okay, 2 questions first. Okay, first one. Anyone solve the first one? Yeah. Okay. Okay. I think you still you want to avoid mistake, you can try to write that assuming that u is e to the x. So let u is e to the x, so that you can have first you can write du, and then du dx like that, and then we can write this uh, ln u, but let me write e to the x, and then the e to the x is just e to the x. Let me write with the bracket. So this part is become x. So we can have x e with power of x. Okay. Okay. I think that's the answer. Now the second one, uh, you look at this is from x to 0. Okay. So what happened if we switch this? Will be negative, right? Will be negative. Okay. Yeah, I think that's not too difficult. So we can write this and becoming right. Let me write here. So the g prime x is just the negative of this 1 plus secant x. Okay. Now what is happen if we have, let me check this. Okay, if you have the antiderivative is, okay, what is happen if you have that? Okay, so you have functions now having the integration from x to x squared. Any idea here? If you have x0, it's easy, right? Mm-hmm. 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 Yeah. Any idea? Really? Well, if you have this, right? This one, 0x, you can calculate, right? We don't have 0 here, right? Why don't we create one? No, 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 that's not subtract, not subtract. Yeah. No, 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 no. Think another way. Think another way. Yes, 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 yes. That's the way. Oh, okay. The screen is disappear. Sorry, sorry. Oh, wait. Why is this wrong? Okay, now it's better. Okay, wait. Okay, here's the screen. Sorry for the disappears screen. Okay. Okay, to solve this, uh, we need to remember that if we have this integration, we can separate this, become x0 and 0x squared. And then we can also switch the first part, become 0 to x. And that way we can have a better results or easy to calculate. The first one is just, let me write, maybe move this right here. The first one is just e with a negative e x squared. Okay. Now the second one, I will directly write. This will be e with the power of x with power of 4, and then multiply with 2x. So 2x multiply with e. Let me write x squared and then squared. So it will be okay. So this way you can solve the integrations. So whenever you have like two at the two endpoints, you have function of x. If you can think one constant that is in the middle of x and x squared, you can separate this into the interval x to 0 and 0 to x squared. Okay. 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 I think one more example, and then we can move to the 5.4. Okay. Okay. Next question is on what interval is the curve is concave downward. Okay. So still you still need some derivative knowledge to solve this one, and it still has we have the integral form, but the question is asking about the concavity, or even maybe another question is asking about the when the function increasing, decreasing, max, min value, concavity, it might have those kind of questions. So within this integral form, the fundamental theorem of calculus, you still need to uh, to remember the knowledge of derivative. First, what you need to remember here is concavity. So concavity, you need to have the second derivative, right? Okay. So any problem from the derivative, like chapter 3, 4, um, in the fundamental theorem of calculus, the integrations, you still have to solve those kind of questions, okay? Like how to find the tangent line, but the function is having this integral. It might be also you uh, look at the textbook, they will have those kind of questions. So the question is what is the interval, right? What is the interval? Okay, so at least first you take the first derivative and let it, because it's just from 0 to x, the integrations. So you just change the t with x, right? Okay, that's the first derivative. Now the second derivative, let me write here. I think we can just directly use the quotient rule. We can write this at the middle. Okay. Okay, this will be, let me write, this will be resulting, this will be negative. So this will be x squared plus x squared plus 4x. Okay. Okay. So if we take this equal 0, this will be x plus 4. And take the line number, we have that is negative 4 and 0. This is positive, right? And in between, it will be negative, and this will be positive. So we need to take this negative, right? Because the concave downwards means that we need to check that is less than 0, right? To have the concave downward. So the interval is from, this will be the answer. Okay, I think that will be the examples. Okay, I think I will give you more example later on. I will upload some questions to the Google Classroom. Okay. 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 Any questions first? Any questions? Any questions from the online students? Do you have any questions? Okay, if we need more practice in class, maybe I will look later if we still have time on Friday or maybe next week. We can still have maybe some examples. And also with your TA tomorrow, we can have more examples. Okay. Okay. Any questions from the classroom? No? Okay. I think we can go to the next section. This is 5.4. This is the indefinite integral. Okay, if we remember the last time we write this, the f is antiderivative. Okay. And we know that the f, if we derive the antiderivative, it will be returned to the original function, right? Okay. Okay, so at the first glance, if you remember the definite integral, this will be resulting in a number, right? But indefinite integral, is resulting in a function. The connections between this indefinite and definite integral is, I think, intuitively you already know that if you have integration from a to b f of x dx, you can write this as indefinite integral of f of x dx, and then you compute from a to b. That's just the way it is, and I think it's already familiar with in your, I think, high school also. I will write several important integral that is usually appear in most of the problem. Let's start from the power functions. And then we have E, we have sine x, we have cosine, all this integration is based on the knowledge of derivative that we already learned, right? Okay, so I think you can also remember from the right to the left. So what is the derivative of tangent x? It's secant squared x, and the integral of secant squared x, then it will be tangent x. Okay, and if you have the 1 over x dx, this will be ln. And remember, for this ln, I think I already told you that you need to have this absolute, this absolute. And then if you have b to the x dx, you have ln, right? If you remember, if you derive b with power of x, you will have b with power of x and then ln b. Okay, so in order to have the integration, you need to divide with the ln b. And then another one is this. This is, oh, this is, I forgot the dx. This is tangent inverse x. Okay, don't forget, in the indefinite integral, you need to always plus the constant at the end of the calculations. And this will be, let's say, the sine inverse. I think this is just some functions that probably will appear. And of course, the very basic one is if you have just k dx. This is, k is just a constant, so this is kx plus c. Okay, now let's move to another one. Okay, other sections. Hope you guys already take notes from here. But I think you can also remember from the derivative. Okay, and let's write some function for you. If I have a tangent and then x with power of 4, if I give you this, the first derivative, okay, we can write secant squared, right? And then you can write x with power of 4 and then multiply with the chain rule. The inside function is 4x cubed, right? With the chain rule. Or if you want to write in a form of u, you can write this. Okay? And if we have the fx, let's say uh, fu is tangent u, then f prime u is secant squared of u, right? If you write the x, we need to take this and then du dx. Okay, and that's why we have x with power of 4, and then this will be 4x cubed. Okay, now from this idea of chain rule in derivative, this is actually giving us an idea how to integrate. Okay? So if I take the integrations of the, let's write the derivative, okay? Let's write the secant squared and then x with power of 4, or let me write the 4x at the front here. Okay. And then we have dx. And then what is this result? Based on what we have calculated from our function's tangent here, this resulted the secant squared, x with power of 4, 4x cubed. So if we reverse this part, we take integration of secant squared, x with power of 4, 4x cubed. The result should be the tangent with x with power of 4. Okay, now the idea why I'm writing the chain rule and let some u into the assumption for x with power of 4, because I want to reverse this process in terms of integral. Okay? So if we let this u with equal x to the 4, let's do the same thing here. Let u is x to the 4, and that is we have the derivative is 4x cubed. Okay, and let's change all the terms. Okay, so this will be integral 4x cubed. Let me write the integral first. Okay, secant squared. This will be u. Okay, and the dx. This will be the dx. So dx is 1 over du. Okay. So dx will be 1 over 4x cubed du. This will be cancelled. And I can have the secant squared u, which is directly, we can integrate, becomes tangent. Tangent u, right? Or in this case, I can replace u with the x with power of 4 plus c. And here we have the idea of the U-Substitution method. So to simply understand the method, you can just reverse the thought process on the derivative. When you have the derivative in chain rule, you can directly derive, and then it's actually you are assuming the inside functions with something, maybe you can rewrite as u, v, any variable you want, right? And when we reverse that, that's actually resulting in this U-Substitutions method. Okay. The important thing in U-Substitution method is how we can identify which one is our U. If you look at this, because we already learned the derivative and we know if we integrate this, it will become the tangent. But if you look just at this integral itself, okay, we have 4x cubed secant squared x with power of 4. Okay, we need to have u. That is, if we replace that u with some terms in the function, and if we derive this u, this 4x cubed need to be cancelled because you need to change this dx, right? So that way, we have canceled this 4x cubed. The problem with this u substitution is how to find or how to identify the correct u. Sometimes when we have this u, maybe it will not cancel completely. We still have the x. And if you have that, then your u substitution will not work. Okay, will not work. Okay. Let me give you another example. Actually, I'm skipping some parts from the textbook because I don't think it's really necessary. Like 5.4, actually, I'm skipping most of the parts. But that is, I believe, um, we have covered that on fundamental theorem of calculus. So not really need to have um, more explanations about the net theorem, the net change theorem. So we can just directly go to substitutions at 5.5. Okay, now we have this. Uh, I think the idea for u we can take from x with power of 4, right? Because if we try to take the derivative, this will result with the 4x cubed, which is the x cubed we can cancel with the terms from the question. So we can have this dx, okay? And then we can write down, we can cancel this, we can write down 1 over 4, this is u5 du. And u5 we can directly integrate with power functions. This will result in U6 or let me write directly. Sorry, 4, 6 will be 224. This will be x 4 plus 2. Let's see. Okay. Now the official substitution rule says that let me write the definitions. So we can operate the x and the u because the x and the u are differentials. Let me give you another example. Okay. Or any questions first? Any questions? No. Okay. Okay. Let me give you another example on how we can use U-substitutions. Evaluate integrations of square root and then 2x plus 1, square root of 2x plus 1. Any idea? Yes. Hmm. Oh, that's from the last week, Friday. And so if we have mm, a x, this is f d dt. Let's say if this is gx, d prime x, which will be fx, right? So this is simply we can exchange this x with t. So whenever we have like this one, I think before this I write something like if you have 1 plus t squared dt, let's say from 0 to x, let's say this is a t prime here will be just exchanging x with t. So this will be 1 plus x squared. Okay, so every time you have this kind of uh, we call this is the fundamental theorem of calculus. You can just exchange x to t or any variable here. We can have u, v, right, aside from x. So if you have this, there's nothing here, right? So we can exchange this to here. But if we have maybe this e to the x, we can exchange this to here, but we need to multiply with the derivative of this because of the chain rule. Yeah. Okay. Mm-hmm. 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 Okay. 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 So probably most of you did the U substitutions and you try to substitute to x plus 1 like this, right? And your du dx is 2, so your dx will be uh, half du, right? So we can write this then half and then writing this is u like that. And then we simply integrate the u with half with power of half. And then this will result it with u 3 over 2 over 3 over 2, right? Let me write this in terms of x. This will result it with 2x plus 1. And this will be 1 over 3 because we cancel this 2. This is 3 over 2 plus c. And that's probably your answer. But if we look and let me write the question one more time. Okay. We can also, okay, instead of looking at this u and then maybe uh, taking this like that, we can just substitute with the u is square root of 2x plus 1. We can square this, okay, and this will be 2x plus 1. Okay, and we can take this derivative. So we can have 2u du, and this will be 2 dx. So we can have this integrations of u, and then dx become u du. So we can have u squared u, or this will be 1 over 3 u cubed, or this will be 1 over 3. This is u is 2x plus 1 half, so 2x plus 1, 3 over 2 plus c. Same answer, right? Same answer, okay. So you can have several ways, okay, for substitution. It depends on identify the u. Okay, now we have another example. I think probably the easy way to look at this u is by taking u is 1 plus x squared. Because when we derive this will result in 2x, in which we can substitute the x with 1 over 2x du. And this way, we can cancel out the x, right? So you can write this x over 2x, and this will be 1 over square root of u, and then du. And then you can find the, let's say the u with power of negative half u, and then this will be half and 1 over half. So this will be resulting, we can cancel that out. This will resulting of square root of 1 plus x squared plus c. Right? Okay, but instead of doing this U substitution, I think last time I showed you that we can have something called advanced guessing. And sometimes this guessing method is maybe more powerful than U substitutions. Okay? For example, the question is asking this x squared plus, or 1 plus x squared, 1 plus x squared dx. Okay. Now, advanced guessing or guessing method, it will depend on how we are familiar with the derivative. Okay. Now, this gives an idea, okay, for the guessing. What is the derivative when we derive? It's resulting something over square root. Okay. Probably, if you think that is, so we can sort some functions. For example, let's say that if our f of x is square root of x. Okay, we can take this derivative. We can have 1 over 2 square root of x. Right? Okay. Let's say we can have squared. This is squared, and it's shifted to half to x. Okay? And oh, I think we get a pattern, right? It's similar to what we have here. Okay, so if f of x is x squared plus 1, so we can just add this plus 1, and that's the integral. So then the integral of x squared of 1 plus x squared dx is square root of x squared plus 1 plus c. And I'm showing you this because sometimes this can be very powerful, and you can do it in your exam. Yeah, you can do it in your exam. This is a valid, okay? Because there is a lot of way to get the integrations, and one way is to give this guessing method. Okay, for example, another way. Let me give you another page. Okay, let me move to another slide. Let me give you another one. You have e 6x dx. I think we can directly write the answers, right? E is still with e, right? And if you remember, if we derive, this will be 6 like that, right? But if we integrate, this will be 6 here. So this is just plus c. Because if we derive this, this will be resulted. So let me write here. So to make it true, then we need to divide this, right? So this is the answer. Okay, so I'm going forward and backward, derivative integral to check. And if we have x, e with negative x squared dx, this can be also look at what we have here. If we have e with negative x squared, okay, and we check the derivative, if we check the derivative, this will result negative 2x e negative x squared, right? The difference is just this negative 2, okay? To answer this, then we need to define the negative 2, okay? So the answer will be negative half, sorry, e negative x squared plus c, okay? So if you think forward, backward as derive, integrate, I think it's faster than U-substitution. Okay? But of course, not all functions will be work out with this, but some functions that you can think easy in your mind, you derive, integrate, it will be very fast with this method. Okay. 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 The other example, if I have the integral of tangent x, dx. Okay. To solve this, we may think this tangent is in sine over cos x, sine x over cos x dx, and then we may try use substitutions to avoid mistake if you want. Okay, so if we have the u is cos x, then the u is negative sine x dx. So we can write this in terms of u. So we can write a negative um, sine x divided by sine x, and then 1 over u du. And this will be resulted with 1 over u. So that is negative ln u plus c. Or let me write directly cos x plus c. We can rewrite this, however, in terms of 1 over secant. Okay? And we can write this in terms of the positive ln secant x, right? I this will be ln 1 and then minus ln secant, okay? And then the minus will result in positive if we write the secant itself. Okay. So integral of tangent x dx is that. Okay. Okay. Now the next part of our lecture is still in substitutions. Let me have some line. So substitution for definite integral. Let me write the definition first. If G prime is continuous on this interval and F is continuous on the range, let's say the U substitute the X, then this is the same as the definition before, but we have the interval now. This will be resulted with G of A to G of B. This is F U D. Okay. I think if you're still confused about this definition, let me give you an example on why on how and why we are doing this. So first, if we evaluate from 0 to 4, is 2x plus 1 dx. This is the one that we already studied before at the previous slides. If we substitute with 2x plus 1, so let half u is 2x plus 1. Okay. We will have du over dx is 2, or dx is half du. So let's try to write that. A term, it's become, this will be half. This will be squared of u du, right? Now, what we need to write also is the interval. Okay, so start with when x is 0, u is 1, right? Based on this u substitutions. When x is 4, u is 9. So that will be our new interval. So we can write from 1 to 9. Okay, that's one way. Or you still can just use 0 and 4, but you need to rewrite into x again. So there's uh, some ways to solve it. So you can write using the x, or you can write using u. The result should be the same. Should be the same. So this will be half 2 over 3 u 3 over 2. Evaluate from 1 to 9. This will result 1 over 3, 9, 3 over 2 minus 1. or this will be square root of 27. 1 should be 26 over 2, right? Over 3, sorry. Okay. Okay. Next is a theorem for asymmetry. Okay. So symmetry. Let me rub it. Maybe this will be the last theorem for today. Um, suppose function f is continue on this interval. Okay. So if the function is even function, that is, you have this, okay, then your integrations from negative a to a, this will be 2 times of this f of x dx. Okay, you can imagine the x squared, right, or maybe sine x. So if symmetry, so this is, let's say this is negative a to a. So it's twice the 0a, or twice negative a0, right? Or you can write 2 0a. Okay, because sometimes my suggestions, if you have integration with some negative, it's sometimes it's um, sometimes you make mistake if there's a negative there. So that's the first one, if even. Uh, Second, if the function is odd, that is, if you have this will result the negative of the original functions, in which when you have these integrations, this will resulting 0, because it's perfectly subtracted with the negative from this odd function, right? So this is saying that f of x minus f of x, that will be 0. I think I will stop here, and I've prepared some feedback for the integral and also feedback for last midterm. I hope everyone can join the feedback. Right. Oh, Laura, I just read your questions. I think that will be the tangent, right? The tangent here. Um, I think still can do. Still can do. Yeah. Okay. Yeah, for the tangent x, I think you can choose the sine x. Okay. Okay. Now let me stop the presentation. Okay, this will be having a two question, and then in the last part we will have some feedback on the midterm. Okay, this will be about the definite integral before the fundamental theorem of calculus. I just want to know, can you solve these two questions? Okay. Okay, I hope everyone is ready. Okay. Okay. All right. Let's start from the checking out how many of you are joining. Okay. Okay, can you join everyone? The online students? Okay. Uh, gonna start. 3, 2, 1. I think it should be okay. I give you a lot of time, 2 minutes. Should be just 1 minute. I think still okay. I think. Yeah, I think you can calculate, and then yeah, if you have the answer, just complete the answer. Okay, everyone has voted. Okay. Okay. Oh, while you're writing your student ID. Okay. Okay. Next questions. Okay. 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 Get ready. Okay. I hope time is enough. Okay, we still have 1/2 minutes. So yeah. Okay, 17 people already answered. Best way is probably draw the graph, draw the graph and see the connections between those informations with the graph. Okay, 40 seconds. Maybe. Yeah, I think you can draw the graph. Okay, 6, 5, 4, 3, 2, 1. Okay. Yeah, the answer is 17. Okay. Yeah, congratulations for the correct answer. You need to draw the graph, and when x equals 3, there will be a change in the graph. Okay, congratulations. Congratulations. Okay. Okay, last part. Last part. This is just a survey. So hopefully you can do the survey. Select which one is suitable one for you. The left is disagree, right is agree. Okay. I would like just to know what is your idea or what is your thought of the exam, the midterm. Okay. 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 4 students already submitted. Okay. Okay. Half students from 14 students, at least half can work all the questions. Okay. I need more time. I still cannot do the questions, although the time is extended. That means that even though I give you more time, you still cannot uh, right answer. That means the question is difficult. That means the question. Sometimes the question is taking times, right, to write. But sometimes the question is too difficult to answer. So it's different thing, right? So I need to know which part for our last midterm. Okay, and the more time. Okay, that's true. So I will use this survey for final exam. Okay, for final exam. Okay, if you already finished all, then okay, see you next Friday. See you next Friday. Okay. So see you next Friday.